For IQA4, the first question reads, you want to determine the speed of the air coming into a wind tunnel. You set up a turbine that displays its rotational rate to determine the speed of the wind. You're worried the turbine will spin too fast and will break. What is something you can change to fix this? And for my answer, I said one easy fix for this problem is increasing the blade radius. By increasing the blade radius, the frequency of rotation for the blade would decrease, seen in the equation V is equal to omega r, where with a constant velocity, an increase in radius will decrease omega. You could also change the angle of the blades. So the second question I ask, what torque is needed to stop the turbine if air is blowing up onto each turbine blade at 65 meters cubed per minute at a velocity of 30 meters per second and a blade length of 20 centimeters? The blades make a 30-degree angle from perpendicular with the turbine. There are 4 blades. So our knowns we know are v dot, velocity, or volumetric flow rate, our radius of the blades 0.2 meters, and theta 30, and we also know the velocity of 30 meters per second. We're going to find our torque needed to stop the turbine. We're going to assume steady flow, incompressible fluids. Later question will cover those two assumptions. And then in properties is the density of air is 1.28 kilograms per meter cubed. And then we set up our angular momentum balance. So tau, or the torque, minus m dot v_r, which in this case will be rho times volumetric flow rate to get our mass flow rate, and we have our velocity, and then our r sine 30 degrees because our blades are 30 degrees perpendicular to the turbine itself. So that is equal to 0. There's no accumulation. We can move that over to the other side and solve. And don't forget to multiply by 4 because there are the 4 blades. And you can see your final answer there. What assumptions are made in this problem that are not necessarily true? So assumptions that aren't really true. There's no incompressible flow. Usually when the fluid is air, if air can be condensed usually, and torque will act on like an incremental lever arm distance. So it's really going to be more complicated. You'll need an integral to calculate the actual torque on the blades.